Welcome to this webinar on Automation Studio E7.1 Educational. This webinar follows a series of webinars we've done over the past weeks where we've created a multi-technology project which included different technologies like electrical PLCs, illustrated views as well. And based on requests that we've received from customers, we've decided to add one, which is how to control a circuit in Automation Studio with real devices as PLC connected through OPC. Okay, so this will be a presentation today that will be done by my colleague George Fatal. So we will be presenting the webinar today, and at the end of this presentation, we'll reserve some time to answer questions. If you have questions during the presentation, in the GoToWebinar application, there's a question section that you can type in your question there. We'll try to answer them as we go, but at the end, we'll be able to actually give you the mic so you can speak out your question, because during the webinar now, there's too many people connected and it would not be efficient to permit questions during this presentation. So George, I will give you the control. Hold on. So, okay. So George, you may unmute yourself.
Okay. Hi, everybody, and welcome to today's session in Automation Studio, where we continue to show you the more functionalities of this amazing software. Okay, today we're going to show you how to integrate Automation Studio to external controller, PLC, and others. And what I'm showing you over here is an example of a system in Automation Studio where I'm going to show you, how this will be integrated to run with an external PLC. So, for example, let me continue over here. What you see over here, I'm just displaying. This is only in a presentation. This is not the real Automation Studio, but this is basically the project in Automation Studio that will demonstrate with others. This is not the only one. There are going to be others also demonstration, but this is one of the system that will show you how it can be integrated with an external PLC. So in this example, what I'm having here, it's a simple pneumatic cylinder where it has to go through a back and forth sequence using the logic over here in this ladder. So basically what you'll see over here is this is the system running in Automation Studio. Actually, it's an animation. It's not the real Automation Studio, but this is basically what it is. Functionality wise, it's start button to initiate the sequence, stop button to continue, to stop, and so on. So basically, what we'd like to discuss over here is how this can happen. How can we do it? So what you really need to build such application, you need definitely the Automation Studio software. You have an external PLC. You definitely have also the programming tools or software used to program this external PLC. And you need what we call an OPC server to communicate with the external PLC and OPC Test Client. And this is what we're going to show you how to put everything together to make all these things happen today. So basically what I'm showing you over here, this is my current setup over in this demonstration. I'm running here on my Automation Studio workstation. I'll show you the Automation Studio interface later on, but now and then I'm having two PLCs running on the same network. I'm having a Compact Logics, which is a Rockwell Allen Bradley PLC, Compact Logics family. And I'm also having another PLC, which is a Koyo Click PLC, which is sold by Automation Direct. I'm showing you two PLCs just to show you that we can add other brands over here. But for the time of the presentation, I'm going to show you two PLCs, and that will demonstrate to you that we can integrate to anything outside of Automation Studio using the OPC technology. So let's start. So basically, when I'm looking to a typical automation problem, what you'll see over here, you have a system, which is basically what we have over here, a cylinder, and then we have IOs, input and outputs, which are the devices that are making up this system. And then we want to, in any PLC program, define the input and the outputs so that we can do the programming for such a system. So if we continue, so basically the problem is the following. I'm having here Automation Studio running in an environment by itself, which is window. And then I'm having externally to the PLC, externally to Automation Studio, the PLC, which is it could be a Compact Logics PLC or any other kind of PLC. And what we want to do is we want to put them together in communication, so that during the communication, Automation Studio will send the status of its inputs, which are these devices which are in Automation Studio, and exchange their value to internal register in the PLC. For example, here I used C1, C2, C3, 4. This is basically typical Koyo nomenclature. If it's Compact Logic, we'll use here the proper tagging, the proper tag names over here for this internal register. What's going to happen after, once this thing's information is exchanged between Automation Studio and the PLC? The PLC will start running, executing the ladder logic. The ladder logic, through the logic here, a status of this internal register, which are the output, will be refreshed after one scan. And then at the end of the scan, we want to send the register to Automation Studio, to the register in Automation Studio, and then we close the loop this way. So, and then this process happens so fast that at the end, the final outcome will be you'll think that the logic is executing in the PLC, and you see the results right away about what's going on the virtual system in Automation Studio. Now, how we'll be interfacing with external PLC, and then basically this is what we're going to do it with OPC. So for the people here that doesn't know what is OPC, I'm going to explain a little bit about this technology. Well, OPC, it's an organization that emerged in 1996 with creating the first standard, which they called OPCDA. And OPC, it's an acronym for OLI process control. And the reason why this foundation came off is in the early 1980s and until 1996, all the Microsoft computer came up in the market, and because in the control industry, no manufacturer of controller was abiding by a common standard. Each one was having his own environment of computers and protocols and standards. It was very hard to make application that runs in the Microsoft PC and then integrate with external controllers. So Microsoft came up with the initiative to bring all the manufacturer of controls in together. Well, actually, there was the big guys, and then to establish a common standard or common way to make everybody, to make the PC communicate with their external with these external devices, and they came up with with the OPC Foundation, and OPC is a acronym for OLI Process Control. Process control is, you know what is process control. OLI is a technology of Microsoft, which is object linking and embedding. Now, the standard made the PC very popular, and over time, they discovered some problems for securities and configurations, and and they wanted also to extend the standard to communicate with other platforms. So they came up lately with what's now called OPC UA, which is the Open Platform Communication. And now the OPC acronym is the acronym for Open Platform Communication, just to show you that now in OPC we can communicate at all levels with all sorts of technologies, even with Internet over Things. And now it's an Industry 4.0 environment, and OPC play a major role into this new Industry 4.0 environment and technology. Okay, so let's continue. So I went over what is OPC, and just to show you very briefly here, before OPC technology, you know, like what we had an application, and then to make the application communicate with an external PLC, we had to write what is called communication driver, and the communication driver was using the manufacturer catalogs for protocols and details, and then we had to write here a very specific program to associate with the application to make the communication with this specific type of controllers. And then what's happening is that whenever we had to change the controller on this side, we had to restart again and writing another communication driver over here. So basically, that was basically the before OPC. Now, once they started the OPC technology, they came up with what it's called an OPC server. Well, basically what they did is that they came up and then they re-engineered this level, this communication driver, to make it look like what it's looking now with a new application which they call the OPC Server. And the OPC Server is not a machine, it's a piece of software that runs within the Windows environment or within a computer, which basically what it does, it contains all the details to communicate with a specific type of PLC or types of PLCs. It can be more than one kind of PLC, more than one make, and basically in this shell, you don't people that do the programming in the application and outside application of Windows, for example, they don't have to worry about the details of communicating with the PLC, because this is guaranteed and handled by the OPC server. What the people need to do over in their application is to include a layer of program called an embedded OPC client, and this is actually what Automation Studio have, which basically this layer will communicate with the OPC server, and this way this interface is a standard interface. It has some syntax rules to do the communication between the client and the server, and this syntax doesn't change. And then what it is just like the syntax guarantees that we can communicate with all reading and writing to any kind of PLC over here, providing that the OPC server support this type of PLC. Okay, so now there was also in this structure, in this architecture, you as tools, you can use any generic OPC client, which is all sorts of applications that you can find on the internet, or even given by the OPC server manufacturer, which really if you use the same syntax that you use in this client interface, it will debug and troubleshoot to make sure that the settings that you do in OPC Server are proper to be able to communicate between its PLC. We're going to look at all these aspects over now in this presentation. So what I'm going to do in this presentation, we are using in Automation Studio the OPC server that we use and favorite use is Kepware. Well, if you look at Kepware, it's a manufacturer. You can go over the website. Okay, let me close the presentation here, and I'm gonna just like, if I get back over here, and then if we go over and you go on your web browser, you can download from their site. If you do kepware.com, yeah. So just here. So Kepware is the company, and then it sells. If you go on products, you're going to find Kep Server EX, and then from there you can either buy it or download the free demo. The free demo is good enough for short demonstration and presentations, and it gives you 2 hours of operations, and then whenever you reach out, you exceed the 2 hour, you had to restart it again and continue doing your demonstration. So for all purpose of demonstration and educational, the free demo version is good enough. So if you download this free software, or not this free software, this free demo, you'll be able to continue in setting up Automation Studio in our exercises. So once you download and install, I'm going to show you over here. You come up with the configurator. Okay, configurator. This is how we configure the OP Kepware server. So this is what you see over here. This is how it looks like, and then I'll show you how. First of all, let's say we want to communicate with a compact logic. So first things you have to do in the connectivity, you have to create a new channel. So here, if you just click on connectivity and right click, give you a new channel. So in the new channel, it will open for you a wizard where it will ask you, it will guide you, take you by the hand to go do the configuration of the channel. A channel is a way of telling the PC where Automation Studio is sitting. By the way, I'm having Automation Studio running over here. This is Automation Studio, same computer. And this is where Kepware is installed. It wants to see how what kind of PLC you're going to communicate with. So the channel, you define the kind of PLC or family of PLC you're going to want to communicate with. So if you go over the wizard, it shows you here all kind of PLC that you can communicate with. So you see here the Allen Bradleys, you see the Automation Direct, you see the Codesys, Cutler Hammer, you see the GE, the Honeywell, the Mitsubishi, the Modbus PLC, Omron, you see the Siemens. So this OPC server is really versatile, that lets you communicate with all kind of PLCs that you are using in your lab. So if I want to communicate with my control logics, Allen Bradley, I'm going to go and select here Allen Bradley Control Logic Ethernet. So this is the kind of PLC or protocol I'm going to use. So I selected. Now the wizard, I'm going to click on next, take me to the next part. Now it asks me to give a name to the channel, and this is how you're going to name the channel. You can name it the name that's, well, for our case, because we are building for you templates that are already pre-configured, you have to stick up with this naming. So here, For the compact logic, we call the channel AS_Rockwell. Okay, so AS Rockwell, next. Now, the next things it asks you the IP address of the PC, and then this is the network adapter. I never use the default. I always like to be more specific and select the IP address of the PLC, because some stations sometimes may have more than one network card if you have more than one network that your computer is communicating with. So to be more specific, you have to select the IP address of the card that is communicating directly with the compact logics, for example. So this is, I have only one card, which is this one. So I'm going to select it and I'm clicking on next. Now after that, there is default value that are there, and then you can change them depending on very specific configuration of network. I always use the default because for me, the default are always working. So I'm going to click on next because default values for me, and I'm assuming also it's going to work very fine for you too. Okay, so I click next until I finish. Now, once I created the channel, the AS Rockwell, now the OPC server know that it will communicate on this channel to compact logics or Allen Bradley control logics PLCs. Now the next thing here is you have to, for each PLC that you'll communicate with, you have to give it a name. So for me also, for the templates that are available in Automation Studio, you have to stick with the name of this PLC. So I'm having here PLC1 because this is the first PLC. Now, after this, it asks you the brand name or the brand of or the type of Rockwell or control logic PLC. For us, it's a compact logic, so you have to select here the PLC that you're working with. Compact logic, for example, 5300. Next. Now, the next things here, this is typically here. This is the address of the PLC on the network. So here I have to put the IP address of my PLC. So the IP address of the PLC I'm going to communicate with, as I showed you in the slide, is 172.16.10.220. And here this IP address is really specific to your network. In my network, the IP address is this for this specific PLC. Now, after this, there is a 1 comma, and then this part is optional. I don't need it because it tells me that this is optional. So I can take out totally. And the CPU slot is always at 0 in my case. So 0 and next. And then after going through this part of address, I go and use the default value that I offered being by the wizard. So I'm going to default value for me are fine. I continue going next, 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 finish. Now I'm done. Now I did the part of configuring the OPC server. So now I have a channel called AS Rockwell, and I have a PLC, which is the one sitting on my desk in my network that I want to communicate with. Now, let's start. Next thing, whenever you do a configuration, you want to test to see if the communication with the PLC is working. So, like I said, you need to launch the software for programming the PLC. And for the Allen Bradley's, is Studio 5000. So I'm using an existing project. This is, you can create a template, for example, for the specific PLC that you're having. Probably you guys knows that in Rockwell, you have to go into a part where you have to define the model and the firmware of the PLC that you're going to communicate with. I created this file, and it's a default file. I call it template. I'm going to use it. So this is the one. It's already configured here. So I'm going to load it. So the file is offline. So I'm in the offline mode here. So I have to bear a little bit because Studio 5000 takes some time. Okay, so here is my project, my template or my blank project. Now to do the testings, and the testings we're going to use the addresses that are working with my template. You have to come in the main program and in the parameter. Okay, sorry. Click on main program and the parameter and local tags. We have to create two tags. We're going to create two tags, which are B for binary, in for this is my binary inputs, and then the type of variable I'm going to use. I'm going to use the bits of this register. So instead of using double int, I'm going to use type int because I want to use 16 inputs and 16 outputs. So the type is int 16-bit. And then I'm going to create another register, which I'm going to call B out for binary out. This is for your output. And then it's int. For you guys that are were doing PLC programming, you're going to come and ask and say, well, why are we doing that? We should be using registers which are, for example, the one that in the PLC, for example, if I go there in the, you're going to find that I have, like register, which are the local register. For example, in the monitor, in the tags, you're going to see here, I can access the local register for input and output, which are directly addressing the I/O cards. In able to be able to do this communication with Automation Studio and simulation, we cannot use the direct inputs and direct outputs card in the simulation. The reason is that because I'm going to be using OPC, the PLC in the scan will always refresh the I/O based on the case of what they are, like how they are, like physically. And this is, I don't want it, because actually it's all the inputs will come from Automation Studio. There is nothing connected. There is no real machine connecting to my logic. So I have to do my logic using the internal register. And then later on, after we do the validation, I'll show you very easy. We can, once we validated the logic, we can get the value coming from the input and the output and map and do the transfer the information to the input and output card and make the program to run on a real machine. So that this part we're going to do it once we do the simulation and the validation of the program. Okay, so I'm having here B in and B out, integer. Now look over here. If I just go and monitor the tags, you'll see that if I click on B in and B out, I can access the register in bits. So I am having bin.0 until bin.15. These are my 16-bit for input, and B out 0 to B out.15 is my 16 output for for the registers. Okay, so now once we do this, I come over here, and then in the PLC, I have one extra step to do over here. And to see the syntax that is used to communicate with these registers, the PLCs, okay, by the way, once we do this, the next part, we're going to do download to the PLC. So I'm going to download this program to the PLC. So I'm going to download it. So you see over here, the downloading is done. Now I am in remote running. So you see, this is actually the real PLC. See here, oops, here it's like, okay, this part I don't need. I'm gonna delete this wrong. Yeah, so I'm monitoring my, this is actually monitoring what's happening in the PLC. Now the next thing is I'm gonna come in the Kepware, the server. I'm gonna click on PLC, and then in the properties, you're gonna see here tag generation. So to see, like how the syntax to communicate with the PLC tags. So I'm gonna create the tags and say okay. So you see over here, it created in this tree another level here to show me how the tags, how I'm going, what is the syntax to communicate with. I'm going to show you in details this part because this is what you need to know in OPC. By the way, this is OPC. So, like what we are showing over here, this is the standard in OPC-DA, and it's very important to understand that because this is what we do over here, we're going to repeat for all the other PLCs if ever you want to go to dive into this technology. So here, the program, so the tag here, if I look at the tag here, the end, I see properties. So you see here, this is, I'm going to copy this thing. I'm going to open here I'm going to show you here a part here where we're going to do, going to use Notepad, for example, Notepad. So Notepad should have opened, yeah. So this is part of the syntax, okay? Now, next part is to test the communication. As I told you, we'll need a test client, and Kepware give you the OPC test client. So you open the test client, and then what we do over here, this is standard in OPC technology. First off, to communicate with the OPC server, by the way, this is another application. This is the OPC server, and this is another application, which is the client, okay? So first thing, you have to connect to the server. So we're gonna connect here. So Kepware is my server, so I made a connection. Now the next thing, I have to create a group, and this is standard in OPC, so I have to create a group. Now the group, you can name it the name that you like. So here I'm going to call it test, and basically the group is a container which I'm going to put in it registers that going to be scanned at a specific frequency out of the PLC. So here the scanning rate is 1000 milliseconds. Let's say I'm going to scan, I'm going to leave it at 1000 milliseconds, which is 1 second, good enough for my testing. And here I'm going to start communicating, tell what I want to communicate with the PLC. So I'm going to add items. So I'm going to add to the group items. So we click here to a new item. And then what you'll see over here, you see over here this tree, because I'm communicating with the server, it will reproduce for me something similar to the server. You see here, I created a channel called AS Rockwell. So you're going to see in the client here, this is Kepware, the server. You're going to see in this tree, you're going to see here a branch called AS Rockwell. And there is PLC1 here. And then in PLC1, you can come over here, and then it gives you the address of the registers here. So for example, if I take this one here, this is a program, main program. This is the tag that it created over here. Let's say I'm going to create with my input. I want to communicate with my input. If I double click here, it's going to write it over here. Let me copy it and put it into here the notepad. So this part is the syntax to communicate with a register in the PLC. Well, basically, to be more specific, because we want to communicate with bits, this is going to communicate with the register by itself. I want to communicate bitwise in the register. I'm going to take out this part and use the syntax that is created, that he showed it to me over here, like, which is in the server. This is the address, okay? So you see the syntax, I have to follow this syntax. And then, for example, I want to communicate with the 0 bit in the register bin, so I put here .0. So if I take all this and then put it into my client here, paste, and then okay. So you'll see over here, I'm going to look at here. You see here, I added twice, so I'm going to just take one of them. So here it communicates with the 16-bit. It gives me the 16-bit value of the register. And here I'm only communicated with the bit 0 of this register, which is 0. Very important to check that everything was set properly is that you're going to find here a column called quality is good. Very important. If quality is bad, that means that you did something wrong with the configuration of the OPC server, or your network is broken, or the PLC is down, anything. But because my PLC is up and the network is, everything is working and set properly, I have to make sure that quality is good. Now, if you see here, like just to show you, like if I put these things in half screen here, and then let's say take this over here. Now, to test to see that I can communicate, you see, if I click on bit 0 and then I do a right click, I can write synchronous right here. I'm going to change the value from 0 to 1. Now look, bit 0 is here. So this is running in the PLC, okay? So this value is 0. So now if I put here 1, and okay, you see here right away, I sent a 1, and I'm communicating with the PLC, and the status is 1. So everything is working fine here. So let's say if I just change it, force it to 0, you see, this is really forcing the bit in the PLC here. I'm doing all this time in the PLC. If I put it to 0, so you see here, the client, which is the other application, show me that the value is 0. So now everything is set properly to communicate with the compact logics. Now, I did the part. Now the OPC server part is done properly. Now I'm going to close this application, and let me go to Automation Studio. I'll go to Automation Studio, and I will load what we have in Automation Studio. We have a template that we created for the compact logic. So if I open my template, and here in the we build this template so that everything is connected here to PLC. What you need to do in your process, in your project, is you connect your electrical wires or hardware to the input and the output, and you properly power up this compact logic. And this is basically what you give to your students to do their projects. Okay, so they start with a template. It's already pre-configured. What they do, they build their circuit over here by connecting input and output to devices in Automation Studio. And then after this, they can write after that their logic in the compact logic using this addressing. This is the addresses of the inputs. Be in 0 to 15 correspond to input 0 to 15 over here wired on this card. and B out 0 to 15 correspond to your output that are going to be wired to the output card. It's 0 to 15. And after that, once they do their program using these addresses in the PLC, they can test and see. And I'm going to do an example to show you how it looks like. So first of all, I'm going to show you that this template works. So what I did here, I just built another application using this template, which is a test for the template. So this is a test for the template. So the project here, well, it's a dummy project, but just to test the template. So here what I did, I just like connected here switches on my input to simulate input signal coming from something, a device or any process in Automation Studio to go to the input. And this is the output, the result that will come to the PLC will, if for each one of this bit, it will trigger here a LED. And here I did the wiring on the PLC as specified in the catalog of the compact logic. And then let's do the testing and see what's happening over here. So I'm gonna just like do this like that. I'm gonna just put this in half screen, put here, zoom all my components. So this is my Automation Studio project. Here I'm gonna put in half screen. So this is actually what's happening in the PLC. So what you expect whenever you have an input, let's say I'm going to put this in simulation mode. Now let me check to see if everything's connected properly. Yeah, here everything is connected properly. Communication is done. Now what you do over here is like, if I just zoom in over here for the inputs, now I have 0, 1, 2, 3, and so on. So I'm going to come over here and click on my input 0. So you see here right away, whenever I'm just clicking on my switch here, B in 0, which is the address 0, is received 1 in the PLC. So you see, so here 1, 0, 1, 2. You see here, look at this 3. So each time I'm clicking over or closing one of these switches, I'm just sending a signal 1 to the PLC as if it's a real card, the signal coming from a real card. Now what's going to happen, like let's say assume that there is a logic running in the PLC, and then the logic will say that I want to activate output 0, so I need to activate output 0. So if the PLC decides that this value is 1, enter. So you see here, it receives, so I'm getting here a light that turn on. So you see here, this is 0, 1, so 0, 1. So you know, like it's skipping because this is actually how the pinout is on the card, and so on. So this shows you that my template here, or which is already pre-configured, is in communication with my PLC. Now let's do a simple program just to, let's say we're going to do a very simple program to show you how to use this template, for example. So for example, here I'm going to use here, I'm going to, instead of using a toggle switch, I'm going to change here a little bit on my hardware. And I'm going to use the NEMA, electrotechnical NEMA, for example, in control. I'm going to use in my switches, I'm going to use a push button here. So let's say I'm going to say this is my start push button. And then I'm use another one, which is going to be a stop. I'm going to do start and stop push button. Okay. Now what I'm going to do here, I'm going to come over here. Let me enlarge this project here, and then 0 and 1. So I'm going to say, okay, for sake of argument, I don't need this. We need some room here. I'm going to take out this part. So let's say, and then I'm going to take the others. For example, I'm going to take this. So, and this one. So basically, or even I'm going to take this part here. So I'm going to use the start push button here and the stop push button. Stop, start. So I'm going to connect. So I connected a start and a stop push button. And for example, I'm going to do a very simple logic that the start push button will turn on the light on 0, and the stop push button will turn off the light. So I'm going to just come over here and okay, just saving time. Let's leave everything wired here. I'm just need only this output to communicate with. So I'm going to come over here in my PLC program. Let's say I'm going to go offline, and I'm going to go in the main routine here. I'm going to create a rung. I'm going to create one rung here. And what I'm going to do here, I'm going to say start. The start, in my case, is going to be wired to B input. So I come over here. This is, you see here, the local. I'm not going to use the local. I'm going to use the B in here. So B0, this is my input. So what's happening here? I'm going to create a B input. It's going to energize here. B output 0, right? And then here, I'm going to just like do a latching or holding contact here, which I'm going to use my B out. I'm going to latch with out. So I'm going to maintain the light. And then here, this is the stop push button. I'm going to create it here, which is going to be in address 1, okay? So this is my program, very simple. So the start button will latch and turn on the light, and the stop will turn off the light, okay? So that's there. I'm going to download the program to the PLC. You see over here, now that's it. Now I can just put these things in half screen here, and this one here, and then I'm going to take over that and then do a zoom all components. And let's start again, program. Now look at this part here, and then if I turn on the light, you see the light here. By pushing on the start button, the light is on, and then pushing on the stop button, the light is off. So you see here, it's very simple. If I use my template here, like you only do the wiring over here, and everything is working. Now, Automation Studio communicate with the PLC via my OPC server that I did the configuration. Okay, so that's basically it. So for a compact logic, Now I'm going to show you another example, like just to show you that we can communicate with other PLCs. I'm going to show you with the Koyo PLC the logic. So for example, if I come over here, the Koyo PLC here this is the Koyo programming, which is the equivalent of Studio 5000. So I'm going to connect to the PLC. So if I do connect to the PLC, see my Koyo PLC is sitting on address 1042, okay, 72, okay, and then if I connect, so you see in the Koyo, I already have the logic that I showed you in my presentation, which is the one that make the cylinder go back and forth. So this is a program for a sequence of a cylinder, okay? So if I open here, okay, first of all, to be able to communicate with the Koyo PLC, I have to come again to my OPC server and to configure another channel. Here, this is the communication with the compact logics. I want to communicate with the Koyo PLC. Now, in the Koyo PLC, if I create another channel, and also in the Koyo PLC, I'm going to use a strict syntax because we have templates for the Koyo. And okay, first of all, we have to select how we're going to communicate with the Koyo. We're going to find that the Koyo is not in this brand, but the Koyo communicate via Modbus protocol. So what you need to do here is just select the PLC communicating in Modbus TCP IP Ethernet. So I select this one, Modbus TCP IP Ethernet, and I'm going to name the channel AS_Modbus. Okay? This is actually what we did, as we did with the Rockwell. We selected the protocol, and from here, as I said, we're going to communicate like using default values. So I'm going, okay, sorry, I went a bit faster. So here in the network adapter, I have to tell it to specify the network where the Koyo is. So in this case, also the Koyo is sitting on the same network as my station, which is, this is the IP address, one car of my computer. And then from there over to the end, I'm going to use the default values. So default value, now the next things here, I click to add the device or add my PLC here, the same thing. I'm going to add PLC1, which is the PLC1, the Koyo, PLC1 in the Koyo network, which is the Modbus PLC1. And then here I'm gonna, it's a Modbus, and then here I have to give it the address of the PLC. So it's 172.16.10. Now the Koyo is sitting at address 42, and then 0 here. This is the way it's in the protocol of Modbus. I'm going to keep it because it was 0 before. Okay, so I'm going to just click here next and continue until the end. So because I'm using default values. Now I'm not going to go over. I know that the setting is the configuration is properly done over here. I'm not going to go over the validation with the OPC Test Client because we did it. I showed you with the Rockwell, but normally you should be doing on your side to make sure that this configuration is properly to go over and start validating and making sure that Quick Client, the OPC Quick Client here communicate with the PLC. So for example, after doing this, because I did, if I just add again, let's say if I do, you're gonna find that the configuration I added over here will start show over here. If I select do communication with Kepware and create a group, which is this part we did, and then so on, like if I go here, add an item, you're gonna find that AS Modbus has been added to the network. And then if I select a PLC here, AS Modbus PLC, and then here I'm gonna take this register here. So you see the syntax over here too. I can copy And I'm going to show it here. Like this is the syntax to communicate with the Rockwell. With the Koyo, it's going to be different. It's going to be like I have to take out this part because this is a diagnostic register. And here I have to add the register address inside the Koyo. And the register address over here inside the Koyo is really a Modbus address. So this is because, for example, here, like you'll find that this register, because it's different PLC, different technology, different standard. So you're going to find that if I open here, this is the registers used inside the Koyo. I'm going to use internal register, as I said. I never use real cards, IOs. Oh, by the way, I forgot to show you, but I'll show you at the end how to make the link between the internal register and the real PLC address, the real card. Okay, so here you see that these are the registers that I'm using in my programming. C register, and then if you click over in the Koyo, the Modbus address, it shows you here the Modbus address of this register, and this is actually what you need to put. So, for example, like okay, well, the address I'm going to put here is 0.16.385. So let's say, for sake of argument, I'm going to do it with you anyway. So C10 is not used, okay? So 16.394. So if I come over here, I'm going to put 0.16.394. So this is the register in the PLC. So if I copy this and then go to my test client here, and I'm going to replace this and then add it. So you see it recognizes it's a Boolean. Then if I add it, so you'll see over here that the value is 0, right? Because it's not used. And here I can force the value. Let's see, there way I can monitor it over here. Let's say I'm going to use a monitor data view, for example. If I go to data view and then come over here and see the register C10, which is this register here, you see it's off, okay? So if I come over here and then go a right click and write to it a 1, so you see the value turn to on. So I'm in communication here. So I can just put the value here back to 0. So it will switch from on to off. So you see off. So I'm in real communication with the PLC. Now, let me put this now in half screen. Okay, let me close this one here. Now, if I put this thing in half screen here, then reduce this part over here. I can come over here and then load my other program. So I'm going to say, I'm going to save it here. I'm going to save project as test 1 here. Now, if I go over here, I'm going to load my other program, which is the one, the example with the Koyo PLC. This is actually the application I showed you in my PowerPoint presentation. So this is it here. So if I check over here, I see that everything is wired properly. See if I just run the application. So you see here, it's the PLC is already running the application. So if I stop it. So, okay, here to see it running in, I put here monitor Okay, so you see here the status monitor. This is actually show you the status of the bits. Now, if I start it here, you're going to see here, like the program that executes in the PLC is the one that is acting on my cylinder to execute the sequence A plus, A minus. Now, if I stop, it stopped, and then start again, and so on. So you see, like showed you that, like with Automation Studio, and Kepware, I can communicate with different kind of PLCs, and I can adapt any project in Automation Studio to work with the PLC. Now, somebody will ask, said, well, okay, that's nice. We've seen how to connect with OPC Test Client to the PLC, but can you show me what's happening in Automation Studio, how to do this configuration in Automation Studio to work with the external PLC? So that's what we're going to do now. Okay, so what I'm going to do, instead of writing my program with the Koyo is like, it's okay like that. This is the PLC program that I wrote as an example using my template in Automation Studio. I'm going to show you how to write the same program, but without the template in Automation Studio, but I'm going to use the HMI library. Okay, so I'm going to stop that here. And then I'm going to start a new project. New project here. I'm going to use HMI. I can use even that. Okay, doesn't matter. So I'm going to. So this is a blank project in Automation Studio. I'm going to come over here. And then remember the project, we had a start and stop button. So I'm going to come over the HMI. So I'm going to use here a start push button. Okay. And then I need the stop push button. Okay. And I need a light. So I'm going to say here, I'm going to put here light here, which is, let's say, I'm going to leave now. So what we're going to do, I'm going to just, first of all, I'm going to come over. I'm going to link these buttons to some variable that I'm going to create inside Automation Studio, which is going to be my interface with the PLC. So I'm going to just create here variables in Automation Studio, Boolean. So I'm going to state for, I'm going to use a specific syntax in Automation Studio for this register, just going to help me later on to do filtering. So all my input, I'm going to write, I put I underscore and give the name of the input. So this is start. I need also to create a stop. So I'm going to create a stop register. I'm created in Automation Studio. And then I'm going to create one for the output, the light. I'm going to call it, let's say, light, L light, output light, okay? Here. Now the next step is I'm going to just link these buttons to this variable. So the start push button here, which is a start push button, I'm going to link it to the start, this register. Now the stop push button, I'm going to link to the stop here, stop. And if I go to the light over here, and then here I'm going to say the light, I'm going to double click and the light. So now everything is linked now. Now before doing the communication with the PLC, I want to show you in Automation Studio what's happening. So I'm going to go from there and open my variable manager. Okay. So I'm going to just display here all the register that have an underscore or with the name. I'm going to filter on the name here, and I'm going to show everything that has something with an underscore something, which is basically my point that I just added. Okay, I can filter here. Okay, I can sort. So you see here, if I go in simulation mode, each time I'm pressing the button, you see the register I start is turned to on. The stop, same thing. Now, if by somewhere my PLC send me a value 1 to this register, so the PLC write a 1 here, so it gonna turn on this light, okay? So no connection, I'm still not connected to the PLC, but you see exactly the process. Now what's gonna happen, as I explained in my PowerPoint, I want to make this register go and communicate with the PLC to write to this register, B in, out, 0, and B out. Sorry, B in and B1 here. And this register, when it's turned on, the communication will send this value, put it back over here. So this is what we're going to do the communication by OPC. Okay, so we're going to close this one. Remember what I did over here when we did with the quick client. I told you OPC technology. We have to create first a connection with the server, and then create a group, and then create an item. We're going to do the same thing over in Automation Studio. Because this is OPC technology. So to do that, we will use what is called in the tool ribbon. You got what it's called the communication manager. So the communication manager will open it, and from there we're gonna communicate. You know, you're gonna have more than one folder over here. We're gonna select the folder called OPC Client DA because I'm using this technology, OPC DA Client. So I'm gonna open this folder. First of all, I'm gonna select the server, and then after this, I'm gonna add here a server. So adding the server, you just right-click over here in the middle. So add OPC Server. Oh, by the way, I cannot because I am in, sorry, I'm in simulation mode. I have to go back to design mode, communication manager again. So I come over here, OPC server, so I can click over here. So click to add a server. Now I'm going to come over here. Remember, this part is the same part equivalent to doing the connection over here. You see, it's going to show me the server that are available. And so I'm actually in Automation Studio, I'm following exactly the standard. So once I select over here my magnifying glass over here, it shows me that Kepware. So this is my OPC server, which is Kepware that I added. So now I added. Now I can use the default value. It's okay with me. I'm going to use the default value. So once I did the connection with the server, the connection is done. Now the next part is creating the group. So I'm going to go over here and create the group. Now the next thing is over here, I'm going to create the group. Now once I do that, here, group, the group I have to connect to, I'm going to create the group, create the server, right? Okay. And here, I did the connection with the group and the server. If I go over here, I can just change the refresh rate from 1000 millisecond to make it fast. I'm going to make it 100 milliseconds. So that's going to make a refresh at a faster rate. Okay. Now, after this folder linkage, I'm going to show in the group one, I have to select the group one. What are the variables? For example, the input. If I filter on input, this is my input variable I created. I want to show them what are the register over here, you know, like what is the address to the server. So I'm gonna just like, for example, I'm gonna start with the start push button. The start push button is at the address 0, so I have to come over here. In this case, I'm gonna use a manual mode because I have to follow a syntax over here. So manual, right? And then you see over here, this is the syntax that the client showed me how to communicate with the bit 0 of the register BIN. I'm going to copy it. I'm going to put it here, paste. And then what type of variable it is? It is a Boolean, binary, Boolean. Now, very important now. Automation Studio will create, generate the value and send it to the PLC. So all the inputs I have to classify, specify here the data, who is generating the data and who is consuming the data. So you see over here in this configuration, the default value is the PLC generating the data, and then Automation Studio will consume the data. This is not true for input. For input, it's the reverse. It's Automation Studio generating the data and the PLC consuming the data. So I have to select this radio button. So for all the inputs, this is the relation between Automation Studio and the PLC. So once I selected the start, and I put my register here for the start. I'm just create a linkage. Now, the start push button now is linked to bit 0 in the PLC. Now, the stop push button is going to be linked to the bit 1, okay? Here. Now, for my output, the output is going to be here, linked to register bout.0, okay? Now also, but in this case, it's not going to be Automation Studio which is generating the variable. It's going to be the PLC generating variable to be consumed by Automation Studio. So it has to be like that. OPC going to Automation Studio. Here it is. And then that's it. So now I did the linkage between the variable in Automation Studio and the PLC. Now, once I did that, now let's see what's going to happen here. So I'm going to put this thing in half, and then I'm going to open here my PLC program. Where is it? It's here. Excuse me. Yeah, it's here. Now I'm going to run, and then what's going to happen, you see here, if I push on my, you see here, each time I'm pushing on my start push button, it turned on this here, and then the light is on. The light is on, come back over here. If I stop, the light goes off. And that's it. So that shows you how to do the linkage in Automation Studio to the PLC. Now, the process I showed you over here is like you have to do it point by point for your project. So you can do it manually, but we also have some tools that we can provide you where it can automate the process by, like doing it in a whole bunch. But this is not the purpose of our presentation today, to show you these tools. If ever people on your side, you want to build some very specific project to do some specific things that doesn't need to use the template, the standard template that we're providing, we can give us a call, and then we'll be very happy to show you how to do it and how to use our tools to automate this process to you. But what I showed you here is how to do it point by point. Point by point, you can do it. For medium-sized project is okay. You can do it once and that's it. But if you really need to speed it up, We have tools for that, and that's it. So that's basically it for my presentation. Well, Christian, we can open now the session for question session for and see if you have any questions, and then we are open to answer all the questions that you're going to ask.
Well, thank you very much, George, for this presentation. It's really interesting, and knowing that once the teacher has created a template, then students don't really need to make these connections. They can just go in and make the layout of the PLC logic and control the PLC, or just write the PLC program in the manufacturer's PLC to control the system in Automation Studio directly. So it's really good. So again, thank you, George, for this presentation, and thank you all for being here today. And if you have any questions, please don't hesitate to send an email to your representative here at FAMIC, and we'll be more than happy to help you. So thanks again, and have a great day. Bye, everyone.